Hello everyone and welcome back at CodingBulls. Today we will continue our beginner C++ tutorial videos and we will take a look into containers and more data types. Let's open up CodingBulls. And first I will show you float, double and long double data types. All three of these can hold a number which is not necessarily an integer. So like 0.02, 11.134 or negative 3.26. The difference between them is that long double is the most precise and the float is the least precise of them. So if you need to use one of these, I suggest using long double. It takes slightly more memory, but it's much more reliable. However, even with long double, it's not completely precise. So let's take an example. Let's say that we want to solve a geometry problem and we need to calculate with the value pi. Obviously, the pi is an irrational number and we can store it properly. We can store a value really close to it, but not the actual value. So our calculations will be slightly inaccurate. And even if we only have rational numbers, we only have 62 bits, which means that we can have 2 to the power of 64 bits. We can have only 2 to the power of 64 different values. It might sound a lot, but this also means that in larger numbers or with numbers with more decimal digits, we can actually have lots of error there. So how do we cope with these errors? Well, first of all, if you don't have to use these numbers, the long doubles and floats, then you shouldn't. If you have to, use long double instead and be really careful. So let's say that we have number like 5.5 plus we add 13.245 together. So this should be equal to 25.745. However, the way these long doubles works, that they store the value on 64 bits, so it might be actually something like this, with a 1 in the end, or 499999878, something like this, so not completely correct. And when it can matter is, let's say that you have a task where you need to calculate and then return the highest number, which is lower than this value, meaning that you want to return the floor for it. So normally, what happens if you cast a long double, double or float as an integer, for example this one, it will become 25. So it will just go ahead and take the highest value, which is lower than this. If you have negative 13.9, it will become negative 14. Because this is the highest integer number that is still not higher than this number. So where you might run into issues, if you have a value of really close to integer, let's say 13.999999 something. So this might actually be exactly 14, but the way we stored it, it will be 13.999, which will result in an error because you will cast this as 13. So you need to be very careful with this. So if you can avoid it, avoid it. If you can't, then you need to know that it's not actually precise. Sometimes you need to work with long doubles and output the result to a console. In these problems, in competitive programming, there is always an error that you need to have. So let's say that your error can be maximum 10 to the power of negative 6. That's the usual absolute or relative error. That means that roughly about the 6 first digits must be good. So let's say that you have a long double C, which should be equal to A divided by D, where A and B are integers that you take from the input. Then you will output C. This is a very easy problem, but it's really easy to mess it up as well. So if we go a bit under this, it seems like a correct code, Yeah, I forgot to include this time. So when I type LT, I mean long tuple. So I need to tell the compiler that LT means long tuple. And then I can change long tuple here to LT as well. So we can go and do that right now. So this code seems correct because we have the two integers, then we divide them, so it has a long tuple and the output result. But if we go ahead and let's say that 2 divided by 3, then it's 0. And if we say 5 divided by 3, then it's 1. Why is this 1? Because the way it works is a and b is integer. So when we reach this line, this expression gets executed first. So we divide a by b. But because they are integers, we store the result as integer. And the way the integer division works is that you take the highest value, which is not higher than the result. So 5 divided by 3 is 1.6666 infinitely. So the integer result will be 1. So instead of this, you first need to cast the value a as a long tuple. And now, if we go ahead and run it and divide 5 by 3, then the result will be 1.66667. As you can see, it's not actually the correct result because it should be infinite sixes. Obviously, we won't have infinite sixes, but we can do something better. So in the output, there is an option called set precision. So we used it as like you were outputting something, but this only changed the settings. And then you can input a number of your precision. If you input set precision 8, then when you divide 5 by 3, it will be a bit longer. If you input 20, then it will be even more precise. So if you need to output a double, you should do this. As you can see, there are lots of sixes now, and it's 3 close to the actual value. And if you have any competitive programming problems, it will accept it because the error is really small. However, it won't be exactly correct, even if you were to increase this value by a lot. You can increase the precision as much as you want, but don't forget that we are only working with 64 bits, so it won't be exact ever. There might be some numbers where your result is exact, but most of the cases it won't be. So if we divide 5 by 3, you can see that we have 1.6666 for a while, but then our bits get wrong and we will have this in the end. So as you can see, it's not always correct. So if you need to use long tuples, be careful with that. Let's take a look at a problem that first we think that we need to use long tuples, but we can actually avoid it. Let's say that we want to tell if a divided by d is equals c divided by d or not. This is just a simple problem, and a, b, c, d are integers. So, and you want to see if they are actually equivalent with just integer division. So you can't use integer division in this example because, as we could see, 5 divided by 3 is obviously not 1, so it would be incorrect. So the first thing you might come to your mind is let's just store these values as long tuple, and then we will have an answer which should be equal to a divided by d is equal to c divided by d. And then, if answer is true, then we will see out equal as real output not equal. So, this seems correct, but there are some issues with this. If you go and build a night, so as you remember, they are not exactly precise with long tuples, even with long tuples. So if we, let's say that we divide 1 by 10 to the power of 9, then we divide 1 to the power of 9 plus 1. Now this will still be correct and say that not equal. But what if we have a float instead? Remember, float is less precise. If you go and read underneath, divide this, it will actually say that they are equal, because we weren't precise enough, and these two divisions ended up at the same number. So as you can see, you need to avoid this. Even with long doubles, there might be some examples that will result in a wrong number, wrong result, but they are much more precise and less likely. But it is very possible, so watch out for it and try to avoid it if you can. So it's not good to use float if you can use long double, but if you can, avoid it or using it at all. So in this example, I can be avoid using it, but we will just take long, take the input, and then instead of division, we say that if we will have the answer as false in the beginning. So if b is 0, it's not 0, and d is not 0, then we don't even hit 0, and it's correct. And then we can, instead of dividing, rearrange this equation mathematically by saying that we multiply by v and d. So this equation is the same, saying a times d is equal to the b times c. So answer will be equal to this a times d equal b times c. And then if we put it at night, and even if we have this input, it will tell us that it's not equal. So if you can, avoid using long doubles. If you can't, then use long double instead of double and floats. And be careful of this precision error. Now let's go ahead and take a look at containers. Containers are something that can contain some variables. So we already took a look of arrays with maximum size, vectors. Now we first take a look at sets. The way set works is you can insert a value to it. Let's say 2. And you insert another value like that. You can erase a value from it. So here's the 5. If you type something that's not there, but it won't do anything, but it won't be an error, that you can insert a value again. Let's say that we already erased 5, and we can insert it again. Or we can insert 2 again. But if you insert a value twice, it will be on in the set only once. Now we fill up the set, and we can try to access these values. One way to do this is a special for function. So the way this for function works is that it goes through the elements of S. You can also use this as a vector if you have a vector. So it goes through a container from the beginning until the end, and goes through each and every single element in order. The way set works is that it contains the values sorted already, meaning from the lowest value to the highest value. In this example, we have 2, we have 5, but we erase the 5, we erase the 1, but there is no 1. We have the 2, and we will have some more values. So we have 2, 5, we will have negative 4, and we will have 99, and then we will have 3, for example. So if we go and build on it, our numbers will be negative 4, 2, 3, 99. Nice in order. So that's how the set works. It will be in order. The downside is you can't refer to the 5th element like this. You need to actually go through the set, which is slower than if you were just to refer one element. You can have an index here, and then in the for loop, increase the value of index so you know which index you are currently at. So this auto in the for loop means that we will define this p value, but we don't explicitly type out what it is. So it will take the type of the variable from what we have here. Oh, we have a set of integers, then p must be an integer itself because it refers to integers. So if we write int here, that's the same thing, but in these type of for loops I prefer to use auto, because even if we change the integer to something else, let's say that we want a set containing long integers or Boolean values, then we don't have to change the auto here. So in my opinion, it's better to just write like this. So another thing we can do with set is that we can take a lower bound of it. So we also have an auto variable, and we will take a look what its actual variable is. Let's say that we will call it p again. Remember that we have this p, but only inside the for loop, so we can call something p here as well. So the way this works is that it takes, and we will have the pair of it, the upper bound. Go ahead and comment this out. So it will take the lowest value from the set, which is higher or equal to 10. So in lower bound, that is okay. But in upper bound, then it's not okay. Here we will take the lower bound, so 10 is fine. Here 10 is not fine. So let's go ahead and insert 10 here as well. And we can also, instead of this, I will just go ahead and take it from the console. We will have size, and we will have a for loop. And then we will put the value inside of the set. If you want to see if you already have the value there, then you can do the following. S dot find the value, and if it's not equal to s dot end, then value is already in set s. Otherwise, that is not in set s. So you might want to do something else here. Let's say that we output that this value is already in set. And here we will just insert it to the s. So this function finds the value and returns a pointer to it in the side of the set. But if we don't find that value, then we will return the pointer to the end of the set. Remember that the end function doesn't refer to the last element, it refers to the element after the last element. So back to the lower bound. It will return a pointer to the element which is higher or equal and this value, and strictly higher in case of upper bound, and it will return the end as dot end if it doesn't find it. So if p equals s dot end, then we will output no element is higher or equal to 10. If we didn't have s dot end, then we will output that the lowest element in set higher or equal to 10 is. And now the way we can get the value from a pointer is we type star and then the name of the variable star p. So if you go ahead and write, we will fill up a bunch of numbers, let's say 5 numbers. We will input 2, then 10, then 13, then 2 again. Now this tells us that this value is already in the set, and then 13 again, this value is already in the set. we will output the values to 1013. You can see that the values that we put in multiple times doesn't get put in the set multiple times, only one time. And the lowest element higher or equal to 10 is 10. And you can see that we should probably output it better, so we will have a double the space here. If we do it right again, and this time we will only have two elements, then no element is higher or equal to 10. So this is how set works. The downfall is that you can refer to the fifth element. So if you want to find the fifth element, it's a bit slower, but there are lots of cool stuff you can do. Maybe in a future video we will look into more of set, but this is the basics of set. So we go ahead and take a look at our next container, which will be map. A map has a key and then has a value. They can be of different types. In this example, we will have integers for the key and the value. And the way you can do this is you say this map, then you say an integer here because the key has an integer value. Let's say I'm string, and then you can assign a value of integer to that key. You can have other stuff as the key. You can even have a string. You can say that apple should be, if you have a string here, then apple should be 12. It's also correct. In this example, we will have integers. So you can say this. You can also assign a negative number, unlike to erase. So you can have a negative number as a key, and even really high numbers. And you can then output this, and this won't increase our memory even if it's really high, and even if we have negative numbers. Maps are really smart in this way. They will only contain memories that we actually need to use. If we have an array, then we will actually take the memory. So if you have a very constant integer too high, then it will take lots of memories. But for maps, even if you refer to a really high value, it won't take too much memory. It will only take the memory that you actually refer to. Now, let's take a look for a simple problem about maps, and we will actually use sets as well in this problem to use maps method. So maps, how maps work is that you can even refer to a value that you haven't defined yet, even like this, but it will always be a default 0 value in case of integers. But maybe you want to do something else if you haven't referred to it. So sets are a great way to deal with this. And we will have two functions to help with this task. We have a void function, which we say that change element, and we will have a key, and we will have a value, and then we will have a int function which returns an integer called get element, and we will have just a simple parameter of k value. So what we will do is that we first insert to the s set, we will use this set, the k. So this set will contain all the numbers that's been already referred and set as a value to. And we will go ahead and change the m key to value. And here in the get element function, if s.find is not equal to s.end, that means that we already changed the element because s is part of the function. So we will return m key. And of course, in the find we need to pass the parameter key. Otherwise, we know that key is not part of the s function, so we don't have this element. So let's say that we have a task where we will have q queries, and in each query we can set a value of the map, or we need to ask it. And if we haven't set the value, we need to output -1. So we will return -1 in this case. So we have the our two functions. Then we will have the main function where we will take the input from the user and we will go through n times, which is our input. And then we will actually have the type of the query. This is also the usual programming competition problem where we will take the type, and if we have type of 1, then we will have two numbers from the input, the key and value, take it from the input, and then we will call the change element function. Very important that this S and M maps and vectors and maps and set needs to be global if you want to refer to them in other functions. So we will change the element. Otherwise, let's say that we have the type 2. And we will have a debug here. If we somehow mess up reading the input, then we will output, so we can see that we messed it up and determine. So in this case, we can have a type of 1 or 2, and in case of a type 2 query, we will have a single value, a key that we will take, and we will output the solution of this get element function. So now if we go and read on it, you can see how this map works. So let's say that we will have 10 queries. We will have type 10 query in the beginning, where we will set the value, the key 0 to 3. And then we will have a bunch of type 1 queries again. Now we update this value 0 to 2. Now we will actually have a type 2 ask of the value 0. And we can see that it's 2. Can see that we forgot to put an end of line here, so it's important. So I will go ahead and close this window. Actually, instead of end line, I will just output a new line, so we will refresh the output. So we have done queries. Type 1, 0 should be 3. Type 1, now 0 should be 2. Type 2, we ask what the key 0 is. It's 0. Now the type 2, we ask what the key 2 is. It's negative 1, we don't have it yet. Then we will set the value of 1000 to, sorry, type 1 query. We set the value of 1000 to 1, 2, 3, 4. Then we will set the value of 12 to 12. Then we can ask the value of 12. Then we can ask the value of 12 again. Of course, doesn't change. Then we can ask the value of even negative 12. It's not there. Then we can set the value of negative 12 to 2, and we don't have to compare this, so it's over. So you can see how this set and map works. Sometimes it's really useful to refer to them as keys and then give values. Now let's go and take a look at our next and our last containers for this video. We will have queue, and we will have the priority of priority queue. So we'll start with the queue, but they are really similar. So we can push a value to the queue. We can push another value. Let's see that we push these 3 values. Then we can go ahead and take the front value and output it. We can pop the front value, which means that we will discard and take it out from the queue. Then let's say that we do this again, like this. Or, which is much better, is that we can have y function and use yq.empty is false. So while we have elements in queue, then we will output the front element, then we will take out the front element. So the way this queue works is that, let's say that we have a store and we have customers coming in. The push function, meaning that the customer steps into the line, and we will go in order. So customer number 1 steps into line. As customer number 3 steps into line, obviously they need to be behind number 1 because they are already in the queue. Then customer number 2 steps into line. And when we refer to the front element, we just peek into who is on the front of the line. So maybe the security guard works there and wants to see who is in the front of the line. It looks at them and see, okay, number 1 is at the front of the line. And pop function is when we actually give the products to the person at the front of the line, and now we say them, okay, it's there, and now you can go. So customer number 1 gets served, so it's removed from the line. We can use these functions in any order we want. So we can, maybe customer number 1 got the products, and now customer number 6 comes in. So you don't have to have all the numbers in order, you can have any number. So number 6 comes in. And then customer number 1 can actually come back if they want to, but they will be in the bottom of the line, like this. So we have number 1 now here. And when we take the front, number 3 will go outside of the store. So this just represents a normal queue, which you would be familiar to. So let's say that we have the following problem. We have, and queue this again. We have for cycle. And by the way, if you want to, if you are not interested in this number n and you will just use it here in the for cycle, you can have a by cycle and type n minus minus. Here it's important if it's a minus minus or minus minus n. If you remember our previous video, n minus minus returns the value n, then decreases it 1 time. So this will exactly repeat it n times, and minus minus n would repeat it n minus 1 times, which is obviously correct. So we can use this, or we can use the for function, whichever is more comfortable for you. I will use this example now. So we will have the type of the query, just as our last example. We take the input. If type is 1, we will add a value. If type is 2, and otherwise there. So let's say a problem is that if we have a type 1 query, then we will take a value from the input, and then we want to push them into the queue. And if we have a type queue, and by the way, you can have the same number multiple times in a queue. It's not like a set, you can do that. So you can have 2 customers with number 1 here as well. So if we have a type queue, then we need to return the front element of the queue. But what if the queue is empty? If the queue is empty and you call the front and the pop function, it will result in an error. So first we will check if the queue is empty. If the queue is empty, then let's say that we need to output -1. If it's not empty, then we will output queue.front. We will output who is at the front of the line, and we will also take them out from the line. So in this example, we have a task where we have a queue system. We can put someone in it, we can take someone out of it, and we need to tell who did we take out. So if we run it, let's say that we have 7 queries. We put customer number 2 to the type 1 query, then we will put customer number 6, type one query. Then we will ask wizard at the front of the line and take them out. It's customer number 2. Then we will do it again, and we will return for the third time. Now no one is the queue. Then we can put customer number 1 in it and take them out. And as you can see, it works correctly. Now our last container is a priority queue. It's very similar with a queue, with a major difference. Instead of storing them in the order of appearance, we store them according to their values sorted. So normally, when you define a priority queue like this, it will take the lowest relevant to the top. So let's say that we have customer number 5 coming in, and then we have customer number 3 coming in. Now instead of stepping on the end of line, like in the last example, let's say that customer number 3 just goes ahead and steps in front of customer number 5 because they have lower number, and that's really cool. And now if customer number 1 comes in, they will step in front of everyone. And if customer number 4 comes in, they will step in the line according to the numbers. Now we might take out customer number 1 this time because they got in the line and they got served. Now if customer number 0 comes in, they will step in front of the line. Now if customer number 11 comes in, they need to step behind the line because they have the highest number. And then if customer number 7 comes in, they will step here. So if you get the concept, the lowest number steps here. We can also do the opposite, where the highest number comes in, and we will do this in this example. So the way you do this is you have actually more options in a priority queue. So this is the default priority queue. You don't need to type these out if you use the default priority queue, but you need to type them out if you want to change it. So the first one is the type that you want to store, integers in this example. The second is the container that you want to store the values, and then the type again. It should always be vector, that's the most important. Just keep it vector and repeat the type here. And last but not least, we have the function that just takes an integer and the creator is from the standard library, meaning that the lowest value will be front and the highest will be behind. If we want to go ahead and change it, we can type less here, and now the highest number will be in the front. So let's say that the store counts how many numbers the customer buys something in the store, and they will just have some privileges for those who shop there more times. In this example, whoever shops there more times gets to cut the line first and get their products faster. So in this example, if customer number 5 comes in, they will step in the front of the line. But if customer number 7 comes in, they bought more products in the store because they have higher number, so they will step in front of the line and they can get their products faster. Now if customer number 6 comes in, they will have to step in front of number 5 and number 7. Now we can take out number 7 because they got their products. Now number 7 actually can come back and they step in front of the line again because they have the highest number. And the customer number 13 arrives and cuts in front of them. So it's a really fun concept, and we can use the same program with the priority queue to see how it works. We change the queue to our PQ, which is our priority queue, everywhere in the code. It works the same way as the queue, except of the change that not the order matters, but the number. And we don't call it front. When we take out the element on the front, we call it top. It works the same way, it's just a different name. So if we go ahead, we can run it. And let's say that we will have 10 queries this time. We can also check that the queue is empty. Okay, now we can put someone in the queue, let's say number 6. And then we can put number 7, then we can put number 5, and then we can put number 13. Now we can see who is on the top, number 13, and we took them out. And then we can repeat it, it's 7, it's 6, it's 5, and now it's empty. So you can see that it will go based on the number further. So these are the containers that I wanted to show you for today's video. Hopefully you liked it. If you did, make sure to like and subscribe, and see you in the next video.